Taking complex conjugate is the operation of replacing I with negative I. The notation for complex conjugate is putting a little bar above the number. So z bar is 2 plus I bar, everything, all of them bar. And that operation just replaces I with negative I. So this is going to be 2 minus I. And this is a number called the complex conjugate of this number. Okay, let's look at the second example. Suppose z equals negative 4i. Then what is the complex conjugate of this number? Z bar equals negative 4 times negative I. Okay, so this is positive 4i. In the next example, z equals just 5. There is no I, so there's really nothing to do. The complex conjugate of this number is just 5. Or you could think of it this way: if z equals 5, then you can write it as 5 plus 0 times I. Then z bar is 5 plus 0 times negative I. But 0 times anything is a 0, so this is 0, and that's 5. Okay, an interesting property of complex conjugates is that when you add or multiply complex conjugate pairs, you're going to get real numbers, no I. Okay, so let's take a look at this example. Suppose z equals 3 plus 4i. So what is z bar? Z bar is 3 minus 4i. Now if you take the sum of 3 plus 4i and 3 minus 4i plus 4i minus 4i, they cancel, and we get 3 plus 3, which equals 6. Okay, let's do multiplication. So 3 plus 4i times 3 minus 4i. And we can FOIL this out. 3 times 3 equals 9. And 3 times negative 4i equals negative 12i. And 4i times 3 is plus 12i. And then finally 4i times negative 4i is negative 4 squared is 16i squared. Now two terms in the middle cancel out, and then we're left with 9, and here I squared is negative 1, so minus 16 times negative 1 is plus 16, and their sum equals 25. So here we get another real number. So this 9 came from 3 times 3, which is 3 squared, and that 3 came from the real part of the complex number. And 16 came from 4 times 4, which is the square of the imaginary part. So here is the formula describing this property. If z is a complex number a plus bi, then z times its conjugate z bar equals a squared plus b squared. And this is called a complex conjugate product theorem. It basically provides a shortcut. So in this last example, if we want the product of z and its conjugate z bar, you can simply take the square of negative 2, which is the real part of the number, and plus the imaginary part of the number, which is 1. Remember, 1 is hidden, that's the coefficient of I, and 1 squared, so 4 plus 1, which is 5.